Hello everybody. Today we are going to be learning about two special right triangles, the 30-60-90 triangle and the 45-45-90 triangle. Let's begin by finding out where these triangles come from. On the left-hand side, up on the top here, I have an equilateral triangle. All the sides are marked congruent to each other. That makes it equilateral. Every equilateral triangle is also equiangular. That means that all three angles are congruent, and we all know that the three angles of a triangle total 180 degrees by the triangle sum theorem. So if you take 180, divide by 3, each of those angles has to equal 60 degrees. All right, I'm going to take this equilateral triangle, and I am going to cut it exactly in half. Now, before I cut it in half, I want to think of a number that's going to be a real easy number that I can cut in half very simply without making any fractions or decimals or anything nasty. So if you're thinking of like the number 10, you can cut it in half and get a 5. That's true. 8, you can cut it in half and get a 4. But what is the smallest, easiest number you can cut in half? And I'm hoping that everybody is saying 2. So I'm going to put a 2 here on each of these sides because I can really put any number I want. And I don't want to get too theoretical. I could really put A or X or something different. But I just want to pick a number that I can easily cut in half and not have to play with any decimals. All right, or any fractions. So here I am. I'm going to cut this triangle in half simply by drawing a line right up and down from the vertex. This would be, it's going to end up being an altitude, but we'll talk about that. If I'm literally cutting that triangle in half, then that 60-degree angle I just drew through is no longer 60, but it is split into two congruent smaller angles. So 60 divided by 2 would make 30. So I'm going to put double arcs right here and say 30 degrees, and double arc right here and put 30 degrees. I don't want to use the single arcs because the single arcs were already taken for the 60s. So if we want to mark things congruent, we got to use the next level up. Okay, so looking just on the right-hand side of this triangle, I can see another smaller triangle. I'm going to try and draw it to the side to the best of my ability here. It looks like this. I'll grab another line. Let me see, it comes over almost here. And then to finish it off, looks pretty good right there. Okay, so I have this 60 down in this corner, 60 degrees. I have this 30 degrees up in this corner. I have this 2 sitting on the long side right there. And let's see what happens on the bottom. You see this length of 2 that was over here on the first triangle, this equilateral triangle? This is what I cut in half, didn't I? And when you take 2 and cut it in half, that's where you get 1 here and 1 here. So this side over here is a 1. Now let's do our triangle sum again. I have this 30 degree up in this corner, and this 60 degree down in this corner. 30 plus 60, if I add them together, I get 90. And if I take 90 away from 180 degrees, because the triangle has a total of 180, and so far we're accounting for 90, we get the other 90. So that means that this is indeed a right angle right in there. So I could come back over here and I could put the right angle, which means I'm going to get another right angle on the other side of it. And basically I could literally fold this triangle in half and get two congruent triangles. The question now is, what is this long leg right here? Looks like I have some kind of a short leg over here. I have a long leg here. And of course then I have my hypotenuse, right? So if I have two sides of a right triangle and I'm looking for the third side of a right triangle, I should be able to know enough to use what? The Pythagorean theorem. And the Pythagorean theorem says leg squared plus leg squared equals hypotenuse squared. And you might know that better as a squared plus b squared equals c squared. But if you think of it that way, then make sure you know that the c is always going to be the hypotenuse. Alrighty, this becomes something squared plus something squared equals something squared. And the hypotenuse is the longest side of this triangle. It is the side that is across or opposite from that right angle. So the hypotenuse is a 2. One of the legs is a 1, and the other leg, I don't know. So I'm going to let my algebra kick in here and let x represent the variable that represents the side of that triangle. Alrighty, this is going to give me x squared plus 1 is equal to 4. I will subtract 1 from both sides of my equation and maintain balance. I get x squared is equal to 3. And there's no number that I know that multiplies by itself to make a 3. So this is going to be some kind of a crazy irrational answer. X will equal the square root of 3. And yeah, I know that I should be introducing a plus and minus sign right there. No doubt about it. If I introduce the square root sign, I should introduce the plus and minus. However, I am well aware of my possible two answers. This could be a positive root 3 or x could equal a negative root 3. Would it make any sense for x to equal a negative root 3 if I'm talking about the length of a side of a triangle? And no, it certainly doesn't. So from here on out, I'm not going to do the plus and minus at all. I'm just going to go right ahead and say x equals the square root of 3. All right, that comes back up here, and we get the square root of 3. So let's see what we have. Anytime you have a 30, 60, yikes, Gina, get back here. Anytime, let me do something here. I'm trying. Keeps moving on me. Yep, I don't want that. This is not working very well for me right now. Get away. Okay, anytime we have a 30, 60, 90 triangle, oh my goodness, this is driving me crazy. Stop this. Every time I put my pencil to the thing, it goes crazy. Stay there. Stay here. Very good, hopefully. Nope, it went back again. You see that? Okay. Well, we got something going here, even though I don't like it. Okay. So every single time that I have a 30, 60, 90 right triangle, the short leg down here is going to be my one side. The hypotenuse is always twice as big, and over here would be a root 3. Okay, so if we can remember that triangle, please try to remember. I'm going to put this nice again. And so much for that. 60 degrees. If you can remember that the 2 goes on the hypotenuse and across from the 30, think about this, 30, 60, 90. Isn't the 30 degrees the smallest angle in that triangle? And therefore the smallest side has to be across from that 30-degree angle. And the smallest number between 1, 2, and root 3 is definitely a 1. So the side opposite the 30 is always your 1 side. The hypotenuse is always your 2 side. And that long leg is always your root 3 side. Okay? So try really hard. Let's see if I can highlight this a little bit with some yellow. Try really hard to remember this triangle. Very good. Okay? Moving on to the square down here. We have this nice square. Hopefully it's a nice square. And I'm going to cut this square in half too, but my goal is to not make 2 more rectangles, is to make a triangle. So the only way that I can take this square and cut it in half to make 2 identical triangles is going straight down the diagonal, right like that. Okay? So it really doesn't matter what I choose for relationships around the sides of a square. I mean, as long as they're all the same, then it doesn't really matter. So I'm going to pick the smallest number I know. I'm not going to cut it in half. So I'm just going to pick the number 1, 1, 1, and 1. And I'm just going to look at half of that square. Half of that square is going to be this triangle right here. So I'm looking at a 1 here and a 1 here. Notice the tally marks indicate the same lengths, congruent sides. And let me see what happens here when I take this 90 degree that's in this bottom right corner and cut it in half. This is going to become 45 here and 45 here. Likewise, up in this other corner, I have this 90. This gets cut in half, 45 degrees here, 45 degrees here, which means that I end up having something called a 45, 45, 90 triangle. It's nothing more than a square cut in half. But here this time, I don't know this piece. This is my x now. Okay, so I'm going to do Pythagorean theorem again. Leg squared plus leg squared equals hypotenuse squared. And something squared plus something squared equals something squared. The two legs in this case are the ones. See how that side right there helps build this 90, and so does this side build the 90. So those are my two legs, and across from that 90-degree angle is my hypotenuse. So the hypotenuse gets my x, and both of the legs are 1s. So 1 squared is 1, and 1 squared is still 1, and this is x squared. I'm going to turn this around and write x squared equals 2, and that means that x is going to be the square root of 2. So square root of 2 shows up on the hypotenuse. Alrighty, that's going to give us a 45, 45, 90 triangle, and the ratio of the sides of a 45, 45, 90 triangle, the sides are always in the ratio of 1, 1 root 2. So I'm going to draw this here again. Let me see. I'm not going to be as specific as I was before. Okay, this is 1, and this is root 2. And yes, we have a 45 degree here. And it was redundant for me to actually name the other 45 because it can't be anything but I will. 45 degrees there. Take my highlighter and please make sure you know that triangle. Both of these triangles are super, super, super important in trigonometry and in calculus. No doubt about it. They are the 30, 60, 90 triangle, whose ratio of the sides are 1, 2, root 3, and the 45, 45, 90 triangle, whose ratio of the sides is 1, 1, root 2. Just notice, please, that in either case, there's some kind of a 2 on the hypotenuse. So in your 30, 60, 90, it's just 2. But in your 45, 45, 90, it's root 2. Now, I didn't really do this with you a moment ago, but I am going to go back. The square root of 3 is approximately 1.7. Oh, so why did I write 1.4? I know why. And the square root of 2 is approximately 1.4. It's like 1.41, 1.73, if my memory serves me right. So if I compare the 1, the 2, and the root 3, it's almost like I'm comparing the 1, the 2, and the 1.73. So 1.73 is longer than 1, but it certainly isn't the longest side of this triangle. It's your long leg for your 30, 60, 90. Okay. Another way you can kind of think about that too is, isn't 2 the same thing as the square root of 4? And isn't 1 the same thing as the square root of 1? So now you're comparing the square root of 1 and the square root of 3 and the square root of 4. Now they're all kind of like terms, so to speak. So the square root of 4 is bigger. So I do end up having some people that will write the square root of 3 on the hypotenuse, and that is not the case. Don't get tricked into that just because 3 is the biggest digit you're writing. We're not talking about 3, we're talking about the square root of 3, which is not 3. Alrighty? So I'm hoping that makes good sense here. Alright, let's practice some examples and see what we can do. I'm going to be redrawing those triangles over and over, and you'll see what I'm talking about. Let's start here with example 1. I am giving you this triangle, and I would like you to find x and y. So first off, I gave you the 60, and I gave you that 90-degree angle right there. So if you had any doubt whatsoever, you could add the 90 and the 60, and that would give you 150 degrees. And you say, okay, the total of the angles in the triangle have to be 180. So if I subtract what I know, then this has to be what I don't know. So 30 degrees is definitely going to go right up into this corner, right up in here. This little dot that I'm putting here, that's 30 degrees. Okay? Now I'm not going to write it in there because I don't have a lot of room with my pen, but that's okay. Alrighty. So I am going to draw, just kind of quick like, a 30, 60, 90 triangle in the same basic position that this triangle is drawn in. And in the typical 30, 60, 90 triangle, here's your 30, here's your 60, there's your 90. The side opposite the 30 gets the 1, hypotenuse gets the 2, long leg gets the root 3. Let's not forget that. These two triangles, because they have the same exact angle measurement, they are what are called similar triangles. Similar triangles have the same basic shape, but possibly different sizes. Okay, not always different sizes, but if the sizes and the shapes match up with each other, if every corresponding piece of one triangle matches every corresponding piece of the other triangle, then we don't just have similar triangles, we have exactly congruent triangles. But in this case, we can say that we're shrinking this triangle because look, the hypotenuse was an 18 and now it's a 2. So it's definitely shrinking. All right, the rest of this is kind of simple. We're just going to use proportions because similar figures have corresponding proportional sides, which means I'm going to take this x right here first. I'm going to compare x in the big triangle to the corresponding side in the other triangle. Now let's see, this x is in between the 90 and the 60. So if you look over here between 90 and 60, the x corresponds to the 1. And then you have to be given, actually, another pair that don't have any variables in them at all. So do you see that 18 and the 2, they kind of make a pair because they're both the hypotenuse of each triangle? So here's 18 compared to 2. And I solve for x this way. I can cross multiply, but if I'm intuitive enough, I know that this is already solved for x because x divided by 1 is x. And 18 divided by 2 is 9. So x equals 9. And that's the end of that x. I'm going to do the same thing. I'm going to start with y. Whatever letter I'm trying to solve for, that's the letter that I definitely put into my proportion first. Okay? So this y over here matches what other side? And I'm hoping you're saying the square root of 3. So y compares to the square root of 3 the same way as, and we already used the other fraction I wanted, same way as 18 compares to 2. And now this isn't solved for y, so it kind of looks like I'm going to have to cross multiply to solve this proportion. I used that word proportion just a minute ago, but a proportion is any time you have a fraction equal to a fraction. And you can undo those fractions simply by cross multiplying. Alrighty, this 2 is going to come up and join that y. I'm going to get 2 times y. This 3 is root 3 is going to come up and join that 18. It's going to be 18 root 3. And now I want to solve for y, so I need to divide both sides by 2, and y is equal to. Now here we need to simplify this. I hope it's exactly what you think it is. The 18 and the 2 can reduce down, become 9, and get 9 root 3. So I have a little saying that I play around with, and when reducing radicals like this right here, and I'm talking about inside, I mean under the radical. And when I say outside, I mean like the 18 or the 2, something that's not under a radical. So I have this little saying I say that when you're reducing, you can reduce inside to inside or outside to outside, but you can never reduce inside to outside or outside to inside. So you'll hear me say that a couple times throughout this thing, and we'll talk about it each time. Alrighty. That is using your proportions to cross multiply and get your answers just fine. I just want to play around with this slightly, just kind of quick like. And I just want to say, you know, I'm going to switch colors here, maybe go for purple for a minute. If this were given to me and I've been studying trig for quite a while, and this 18, I don't like the size of that, we're going to go down. This 18 were given to me here. And I wanted to find this side here, whoops, sorry. And I knew that this was a 60, and I knew that this was a 30. This is kind of simple to do, because the side opposite the 30 has to be half of this hypotenuse, which was 18. If you just remember where this thing came from an equilateral triangle being cut in half. So down here, this whole base was an 18. But if I cut it in half to form the 30, 60, 90 triangle, well then, x is simply 9. And do you remember that that long leg had a root 3? You can take this short leg right here, this 9, and you can just say, okay, this is 9 root 3. Just attach a root 3 to the end of it. And you get the same thing we got by going through the proportions. So when in doubt, make proportions, do it out. Okay, you can rewind that if you feel like it, but we're going to move on to the next problem, okay? Alrighty. Example 2. I see another 30, 60, 90 triangle. Now I only see the 30 and the 90, but you're never going to have a 30-degree angle and a 90-degree angle without also having a 60-degree angle. So I could go ahead and put a 60 in there if I wanted to. I'm just going to leave it the way it is. I'm going to draw another 30, 60, 90 triangle in the same basic position that that one is. This is my 30. This is my 60. Across from the 30 is my 1. The hypotenuse, which is down here, has to be a 2. And this long leg is my root 3. And I'm going to make proportions because these two triangles are similar with each other. So I start with my x. X compared to what? Okay, and I'm hoping you got the root 3 out of me. But the x is definitely the side that's in between the 90 and the 30. So you basically search for the side over here in between the 90 and the 30. And if you draw it in the same direction, you're going to just be right on top of it. So x compares to root 3 the same way as, now what pair of numbers did I give you? 6 root 3 on the short leg compares to 1 on the short leg. And I'm going to cross multiply and solve this. I have to cross multiply. Well, I guess I don't have to, but this isn't x over 1, so I don't already have x solved for. So the easiest way to just tell you how to do this is to always cross multiply. This gives me 1x is equal to 6 root 3 root 3. Now remember, when simplifying radicals, you can multiply inside to inside, outside to outside, but never inside to outside or outside to inside. So in this case, this gives me 6 times the square root of, 3 times 3 is 9, and then the square root of 9 is just 3. So x is 18. All right, you know, it would be really nice if most people already got the fact that the square root of 3 times the square root of 3 has to equal just 3. The square root of 3 represents some value that I don't know off the top of my head other than 1.71 something something. But the square root of 3 represents a number that when you multiply it by itself, you get 3. And what are you doing? You're multiplying it by itself. So what had you better get for an answer? The 3 back. So hopefully from here on out we can just skip down there, okay? All right, let's solve for y. So we're going to start with y because that's what we're solving for. The y right here compares to the 2 side over here is equal to, and we're going to use again 6 root 3 compared to 1. Now we're going to cross multiply. And this gives me 1y equals 6 root 3 times 2. And we're going to multiply inside to inside, outside to outside, but never inside to outside or outside to inside. So the outside and the outside make 12, and then we just say root 3. And that finishes that problem. Okay? I am going to actually try and draw this one more time. I want to switch my color and go to that purple again. I'm going to come over here and just a little more conceptually, without doing so much algebra, if I had this picture like this with a right angle here, x 6 root 3, 30 degrees, and I wanted to find y, first thing I'd probably put the 60 in there. I'd say, okay, across the 30 is 6 root 3, and then the hypotenuse would have to be twice as much. So this is going to be 12 root 3. See how fast that is? The y is going to equal 12 root 3. And then here I have the 6 root 3 on my short leg. If I take the short leg and I multiply 6 root 3 by root 3, that is going to give me 6 times 3, 18. X is equal to 18. And they sure and do match up in both cases. Alrighty? So you can think about it, think about it, think about it. Let's see. Let's move on just a little bit, okay? Here's example 3. Yeah, I made a great big triangle for that one, didn't I, for some reason? Okay, well, I guess that number 20 tells me why. There's a 20 there. I have a 60-degree angle and a 90-degree angle, so obviously the other angle has to be 30. So I'm going to draw myself a 30, 60, 90 triangle. Oops, not like that, I guess. I can just draw it anywhere, really. Just get the idea across here. 60, 30. Notice I'm putting it in the same position as the original triangle is already drawn. I go across from the 30 and I put 1. Hypotenuse is a 2, and that long leg gets the root 3. Okay, so here we go. I have x on the big triangle compares to 1 on my little triangle. Remember, these triangles are similar with each other because they have the same angles and therefore their sides must be proportional. X over 1 has to equal, now what dimension did I give you over here in this triangle? I gave you this 20, matching what? Root 3. Think about it. Isn't this 20 right here? Isn't this on the long leg? So the long leg is always going to match the root 3. The short leg is always going to match the 1. Alrighty, so intuitively here, x over 1 is just x. So I've pretty much got this thing solved for. X is 20 divided by root 3. The problem is I can't leave any tenths in the basement, so my math teacher used to tell me. And a tenth would be your square root sign. The basement's the denominator, so no tenths in the basement. That square root of 3 must be eliminated from that denominator. So I'm going to do something called rationalizing the denominator, which means I'm going to multiply by another root 3 on the denominator. However, what I do to the denominator, I must mimic on the numerator. So square root of 3 times the square root of 3, hopefully you know that right off the top of your head, like I said a moment ago, equals 3. And this gives me 20 root 3 on the numerator. Now, this is still not a rational number, but at least the denominator is rationalized. So the answer to this problem is x equals 20 root 3 over 3. Now, if you're allowed a calculator, you can just throw that right into a calculator without rationalizing. You could put 20 divided by root 3 and just get the decimal approximation that way. But for our purpose right here, because I know you guys are going into calculus, and calculus we don't simplify, we don't throw the calculator down for everything, so we want to be able to know how to simplify all these. Alrighty, let's find y. The y is the hypotenuse, so the hypotenuse always gets my 2. And that's equal to, again, 20 divided by root 3. So I'm going to cross multiply here, both sides of the equation. Or, you know, smart, you could just times both sides by 2. But I'm going to cross multiply because I told you that's how we were going to do this. So I have the square root of 3 multiplied by y is equal to 2 times 20. And I'm just going to write 40 down there. I'm going to divide both sides by whatever's attached to that y as a factor, and we're going to divide by root 3, and this is going to give me here y equals 40 over root 3. Well, I can't leave that root 3 there, so I need to multiply by root 3 over root 3, and this is going to give me a y value of 40 root 3 divided by 3, and that is the answer to that problem. Alrighty. Okay. Well, I guess we could talk this out a little bit more intuitively. However, this gets the job done to go ahead and write your proportions. I guess let me just put something out here for you. If you have a 30, 60, 90 triangle, and you know this side right here, I don't care what it is, we make up the letter A or something for the side opposite the 30 right here. That one. Well, then the hypotenuse is twice as big. So twice as big as A is 2A. And the long leg always has a root 3 on it. It's whatever the short leg is multiplied by root 3. So this long leg becomes A root 3. So here you can start to develop a few rules. Like if you know your short leg and you want to find the hypotenuse, you simply double the short leg to get the hypotenuse. But if you know the hypotenuse and you want the short leg, you would take the hypotenuse and divide by 2 to get the short leg. If you knew the short leg and you wanted the long leg, you would take the short leg and multiply by root 3 to get the long leg. Or if you knew the long leg and you wanted to get the short leg, you would take the long leg and divide by root 3 to get the short leg. And I wouldn't suggest any combination of anything to jump from the hypotenuse to the long leg or vice versa from the long leg to the hypotenuse. Your goal should be to find that short leg. If you're going to be doing anything mentally, doing any mental math, find that short leg first. And from the short leg, you can always multiply by either root 3 to get to the long leg or by 2 to get to the hypotenuse. But your goal is to get that short leg. Once you have the short leg of a 30, 60, 90 triangle, it's all multiplication to get the long leg and the hypotenuse. Okay, so just to bring you back to this question then, if all I had was this 20 right here on the long leg, I should know enough to take 20 and divide it by root 3 to get my short leg. And look at the proportion that you set up, that I set up. It actually does say 20 divided by root 3, doesn't it? And then you rationalize, and you get 20 root 3 over 3. That gives me the short leg. So I'm going to, when I said rationalize, by the way, I meant rationalize the denominator. I'm sorry. 20 root 3 over 3 is still very much an irrational number. But like I said earlier, the denominator gets rationalized. So 3 is a rational number, whereas square root of 3 that used to be in the denominator was not. Okay, so you get that short leg as being 20 root 3 over 3. All you got to do is double that to get the y value, to get the hypotenuse. And look, 20 root 3 over 3, if you double it, you just double that 20, doesn't it become 40 root 3 over 3? It's that fast. But thinking a little bit shorter requires you to think a little bit smarter. Okay? So we think smarter, not harder, and we get the job done faster. All right, let's move on to question 4. Alrighty. So here I am on question 4. What's given to me is that long leg of 6 root 5. I could do this right out loud, right in my head, and you could just follow along with me, or we could set up proportions. So setting up proportions is a go-to. It works every single time. But people sometimes mess things up when they do these things in their heads. Okay? Well, let's go ahead and set up a proportion here. This triangle will be similar to any other 30, 60, 90 triangle that's just like this. So I'm going to kind of make this. This is my 60, this is my 30, and I guess I didn't even talk to you about that, did I? But in this original question, number 4, I marked the 90-degree angle up here, and I marked 30 degrees. So you can't have a 90 and a 30 without having the other one be a 60. All right? In the 30, 60, 90 triangle, the short leg, which is the leg across from the 30, is your one side. Hypotenuse is your 2 side, and the long leg is your root 3 side. So we're going to start with x, and we're going to say x over, let me see, this x right here matches what side? I hope you say 1, because x is the short side here, isn't it? Isn't that the short leg? Okay, so x over 1 is the same thing as the comparison of 6 root 5 to root 3. Now x over 1 is x, so this is just x equals. Oh, no tenths in the basement. I see that square root of 3 in the bottom right there. I need to get rid of the square root sign. I don't mind the 3, I just don't like the square root of 3. So we're going to multiply by the square root of 3 divided by the square root of 3. And that will just make plain old 3 in the bottom, which is nice. Now the denominator is rationalized. But on the numerator, I have 6 root 5 times root 3. And remember, you can multiply inside to inside, outside to outside, but never inside to outside or outside to inside. So that means that the root 5 and the root 3, 5 and 3 are both inside, so you can multiply them. This gives you 6 root 15. Oh, now I can go even further. Look at this. I can divide inside to inside, outside to outside, but never inside to outside or outside to inside. So the 3 and the 6, they're both outside. I can go ahead and reduce those. 6 divided by 3 is 2. So this answer is just 2 root 15. Done. All right, let's find y. I'm going to erase my little circles that are here on my x's, and let's do y. Y compares to what? 2? Isn't the y on the hypotenuse in the big triangle? So I want to grab the hypotenuse in my 1, 2, root 3 triangle. So y compares to 2 the same way as my long legs compare to each other. 6 root 5 compared to root 3. So I'm going to go ahead and cross multiply. This is going to give me y root 3 is equal to, now what's 2 times 6 root 5. Remember, inside to inside, outside to outside, but never inside to outside or outside to inside. So I can multiply the 2 times the 6 and get 12. And then root 3 stays there. Now I'm going to divide both sides by root 3. Oh, it's not root 3, it's root 5. Thank you, Gina. Divide both sides by root 3. Divide both sides by root 3. And now I get y equals. Well, I can't have that root 3 in the denominator. I definitely need that root symbol off my denominator. No tenths in the basement. So I need to multiply by root 3 over root 3. And I guess I should just mention here that the 12 and the 3 cannot divide off. The 12 is outside and the 3 is inside. And we can't divide outside to inside or inside to outside. And the 3 simply doesn't go into 5, so the square roots don't divide off. This yields for me 12 times the square root of 15 all over square root of 3 times the square root of 3 is 3. And then I can divide the 12 and the 3 because they're both outside. Remember, inside to inside, outside to outside, but never inside to outside or outside to inside. This gives me 4 root 15. All that work when really you could have just taken that short leg and doubled it to get the hypotenuse. Cuckoo! That would have been smart if we had been thinking smarter, huh? Think smarter. You don't have to work as hard. Alrighty. So I think we'll just mosey on from there, okay? Let's get on to question example 5. Okay, so I again have a 90 and a 60, which means the other angle must be a, you guessed it, 30. I know I haven't been marking them, but I just felt like that one. So this is a 30, 60, 90 triangle. So I'm just curious what happens if instead of setting your triangle up exactly like that, what if you just always drew your 30, 60, 90 this way? The way we did when we created it. 1, 2, root 3. Let's see. Let's see x here. X compares to what? Now would the x be on the 1 side, the 2 side, or the root 3 side? And I'm hoping that you get the fact that the x is across from the 30. So what's across from the 30 here? That's your 1 side. This is equal to 12 times the square root of 15 compared to, now the 12 root 15 is on the hypotenuse here, right? And what's on the hypotenuse over here? This is your 2. So the hypotenuse matches with the hypotenuse. Those are corresponding sides. So x over 1 equals 12 root 15 over 2. Inside to inside, outside to outside, but never inside to outside or outside to inside. X over 1 is x. 12 divided by 2 is 6. This gives me 6 root 15. And let's find y. I have y over. Now what side is the y on? This is the long leg, and I've been referring to the long leg as the root 3 side. So y over root 3. And, you see here, this y matches this root 3. And if you think about that, the side y here is the side that connects the 30-degree angle and the 90-degree angle. Same up here. Here's your 30-degree angle, here's your 90-degree angle. You connect them, that's your root 3 side. Is equal to the hypotenuse, 12 root 15, divided by the hypotenuse, which is 2. So I'm going to cross multiply these things. I'm going to get 2y is equal to, and I have 12 root 15 times root 3. You know, I think it's worth actually writing this out. Because I do something a little bit different that most people don't do, I think. I actually think of that root 15 as being 2 other roots, and then my root 3 is still here. So can you see, just like I can see, that 15 has a 3 as a factor embedded inside it? And that 3 as a factor can get paired up with the other 3 that's a factor under the root sign over here. And I'll be left with a root 5 underneath there. So the square root of 15 is the same thing as the square root of 5 times the square root of 3. And that allows me to pair these root 3's up here and just call that just plain old 3. Multiplied by this 12 is going to give me, I'm going to write this up here a little bit, okay? This is 2y is equal to 12 root 5 times 3. Well, 3 times 12 is 36 root 5. And this is, whoops, sorry, 2y. Divide both sides by 2. And the 2 can divide into 36, right? Outside to outside. And I get y equals 18 root 5. 18 root 5. Alrighty. We are going to move on from there. Okay. Scroll down a little bit here. Example 6. Here we go. Let's see if we could probably do it without even drawing the other triangle. But let's go ahead and let's just draw that other triangle to drill it into our minds, okay? You can put the 30 and the 60. This is how I always draw my 30, 60, 90 triangle. And then I say 1, 2, root 3. But if you'd like, you can draw the triangle the same way that other one is being drawn with that 90 right there. Yeah, I don't like that either. Okay, so I have a 60 here and a 30 here. These match. Across from the 30, here's your 1, your hypotenuse is 2, this is root 3. All of these triangles are similar to each other, okay? And similar triangles have corresponding angles that are congruent and corresponding sides that are proportional. So let's start with my x. X is on what side of your 30, 60, 90 triangle? Is it on the short side, short leg, long leg, or the hypotenuse? I'm hoping, since you know it's across from this 30-degree angle, that you're saying, oh, that's on the short leg, which matches the 1. This x matches this 1. Okay, across from the 30 is equal to, and then the other side that's given as a measurement in this triangle is 5 root 6. And what side of the triangle is that on? What does that match? Which length of the side is in between the 90 and the 30? So that would be right over here, in between your 90 and your 30. This piece here, whoa, go back again. This piece right here is your long leg, and your long leg matches the root 3. So this turns into an easy problem. X over 1 is just x. 5 root 6 divided by root 3, inside to inside, outside to outside, but never inside to outside or outside to inside. Just so happens, root 6, root 3, they're both inside. This is going to give me 5 root 2. Very good. Let's go for y. So I'm starting off y over. Now y is the hypotenuse. So I can tell it's the hypotenuse because if I draw an arrow from that 90 degree to the opposite side, there's my hypotenuse. So I can do the same thing over here. The hypotenuse is, without a doubt, that 2 right there. So y over 2 is equal to the same pair that I had already given to me as numbers, 5 root 6 divided by root 3. So I can cross multiply this, or you could have cleaned it up a little bit first. It's up to you. I get the square root of 3 multiplied by y is equal to 2 times 5 root 6. Well, 2 times 5 root 6 is 10 root 6. All right, outside to outside. And then if I divide both sides by root 3 to solve for y, I get y equals 10 root, what? Square root of 6 divided by square root of 3? That gives me 10 root 2, which shouldn't be a surprise because x was the short leg. This was the short leg. And this is my hypotenuse. And if you take the short leg and you multiply by 2, you get the hypotenuse. 5 root 2 times 2 is 10 root 2. That makes sense. Alrighty, move on to number 7. Oh, this is a doozy, but these are my favorite ones actually. So in number 7, the original triangle ABC is a 30, 60, 90 triangle. Can you see it? It's the biggest triangle there. And then line CD is drawn, line segment CD is drawn right through the triangle. It doesn't cut the triangle in half by any means, but line CD is what's called an altitude of triangle ABC because it is a line drawn from vertex C perpendicular to the opposite side. And that's a definition of an altitude. You start at one point on your triangle and you draw a segment perpendicular to the opposite side and you get what's called an altitude. Every triangle has 3 altitudes. This happens to be the one drawn from angle C. Alrighty, now when this happens, a lot of good stuff takes place. So I think I'm going to switch my color. I think I'm going to go into green just to be different, and I'm going to write some things out that I know. This 30 that's up in here, this 30-degree angle, yikes, let's get down and get narrow. I doubt highly if they're going to let me get rid of that. Yep, I knew that was going to happen. Okay, so I'm back on my green. Good enough. All right, so if this is 30 up in this top corner for A, and I see this 90 over here, then this over here must be 30 degrees. Oh, sorry, 60 degrees. That was kind of silly on my part. 60 degrees. Because this triangle that is on the top of triangle ABC, one of the ones that's embedded in it, I like to call it the medium triangle. I like thinking of triangle ABC as the big one, and then we have a medium one, and then we have a baby one, kind of like Goldilocks and the 3 triangles. Anyway, we have the medium-sized triangle right there. Now, if angle C in its entirety is 90 degrees, which it is because I have a little box there that says 90 degrees around C, and I know that a piece of it is 60, well, doesn't the other piece of it have to be, what's 90 minus 60? And I'm hoping you said 30. That's not the only way I could have got that 30 either. Because if you look at the big triangle ABC, which is drawn, of course, these are congruent to each other, these first two. This first triangle, I should say second triangle, the big triangle. This is my big triangle. This is my medium triangle. And this is my baby triangle. Okay? Or small triangle, I guess would be really nice to say instead of baby. Small. But in the big triangle, I have a 30-degree angle and I have a 90-degree angle. So therefore, I must have a 60-degree angle, which means this angle B over here has to be 60. You just kind of imagine that the middle thing isn't even drawn, and then you can see the great big triangle. Okay? I don't want this to get too messy though, so I'm going to erase that. All right. So now the medium triangle. Way up high on that medium triangle is going to be side A, or angle A, right here. This angle A is still this angle A. Can you see it? And then what happens down further? I mean, this is 30 degrees here. So how many degrees has to be right in here? Just curious. If one of the angles is 30 and the other is definitely 90, then doesn't this have to be a 60 down in this corner? So if this 60 is down in this corner, then that has to match this 60 that's over here next to C. That means that this is a C right there. And if that's your A and C, well, what's this right angle going to be right in here? And what's this right angle right there that I'm tracing? I'm thinking D right here. This is this. So this is D. Matter of fact, in the baby triangle, D is your right angle as well, isn't it? Right over here in the baby triangle, isn't the D the vertex of this right angle? The 30-degree angle has C as the vertex, so I'm going to put my 30 right here with the C up on top. And then, of course, right here, B has a 60-degree angle right in there. Okay? So there are these 3 triangles, and these 3 triangles each have 30, 60, 90 angles. So these 3 triangles are similar with each other, which means that their sides must be proportional. So I was given this 6. CD is 6. Where do you see a CD? I see a CD right here. And you know, I think I'll switch colors one more time. This is a 6 right here. You know what? I don't want that to be my... There you go. That's a 6 right there for CD. And CD is also in the baby triangle, isn't it? The long leg of the baby triangle. So that's kind of cool that the line that gets drawn here, this altitude inside your great big triangle ABC, becomes the short leg of the medium triangle, but it becomes the long leg of the small triangle. This is my medium triangle, this is my small triangle. Okay? So think about that just a little bit. Try to make sure we have things. And let's see. Do you think there's anything else that we can find? All I gave you was that 6, huh? Should be able to find a whole lot of stuff. Okay, well, let's take our, let me see. I think the medium triangle looks pretty simple to play with because isn't the 6 on the one side? Just to think about that, okay? You got to get this triangle in your head. This 30, 60, 90 generic triangle that is similar to any other 30, 60, 90 triangle. The side opposite the 30 is your short leg, and like I said, I call that the one side. The side opposite your 90 is the hypotenuse. That's your hypotenuse. I don't call it, well, you can call it the two side if you want, but I usually don't. And then the last thing is your long leg, and it's definitely the leg across from the 60, and that is your root 3 side. Okay, so we are 1, 2, root 3. So this 6 right here is kind of like this 1 right here. So all I have to do is double it, and I'll get the hypotenuse. So if I take 6 and I double it, I get 12 right here. Suppose it only makes sense if I'm going to make my numbers thicker that I should go ahead and choose a thicker font there. Okay, so I have a 6 on my short leg. I have a 12 on my long leg. What do you suppose, 12 on my hypotenuse. What do you suppose goes on my long leg? I have that long leg in my mind here. So whatever the short leg is, remember, if you multiply by root 3, that gives you the long leg. Whatever the short leg is, if you multiply by 2, that gives you the hypotenuse. So I'm going to take this short leg and multiply it by root 3, and that will give me 6 root 3 on that long leg. Is that making any sense? I hope it makes some sense. Alrighty. So what else do we know? If you get stuck finding some other things, we can make some proportions. Okay, you see that AC is 12? I see an AC in the big triangle. Can I come over here and just write 12? This AC right here, this is the hypotenuse of the medium triangle, but it is also the long leg of the big triangle. So you're going to see it in both triangles, but that 12 will be in a different position, just like you saw the 6 in the medium and the small triangles, but the 6 was in a different position. For the medium triangle, that 6 was on the short leg, but in the small triangle, the 6 was on the long leg. Alrighty. So if there's nothing else you can seem to think of off the top of your head here, I'd really like to get, let's say, this short leg. So let's go ahead and let's say x compares to what? The short leg is over here, so this x is comparing to 1, the same way as 12 compares to root 3. So x over 1 equals 12 over root 3. So this is just my x. X over 1 is x, so I can say x equals, and I need to get that tent out of the basement, so I need to rationalize that denominator by multiplying by root 3 over root 3. That gives me 12 root 3 over, I don't like that, 3 over 3. And now the 3's don't divide off, but 3 is on the outside, 12 is on the outside. So you can divide off inside to inside, outside to outside, but never inside to outside or outside to inside. 12 divided by 3 gives me 4, and this is 4 root 3. So I'm going to come over here, and I am going to put 4 root 3 where the x was. Okay. Alrighty, what else do we need to know? If we know that this particular short leg is 4 root 3, can't I find this hypotenuse pretty quick like? Please tell me yes. What do you do to go from a short leg to the hypotenuse? To go from the short leg to the hypotenuse, let's bring this back into play. If I have my short leg and I want to get my hypotenuse, all I have to do is times by 2. So multiply by 2. So I'm going to take this 4 root 3 right here, and I'm going to multiply this by 2. And what is 4 root 3 times 2? 8 root 3. And that finishes that triangle. Let's see, what other triangle do I have to finish? I got that baby triangle. I want that small triangle. Hey, look what I just found, that x, which was side CB or BC. That was 4 root 3 right here. Isn't that the same thing as what's over here? So the short leg of the original big triangle, let's see if we can figure this out. The short leg of the original big triangle is also the hypotenuse of the baby triangle, and it sure is. So if I found the short leg of the big triangle to be 4 root 3, well then this over here is also going to be 4 root 3. And then if I know the hypotenuse of my small triangle, which I just found, 4 root 3, then how do I go from the hypotenuse down to my one side? And all I have to do is divide by 2. So what is 4 root 3 divided by 2? And I'm hoping you're telling me that is 2 root 3. And I have everything there. So let's answer these questions. What is side AC? AC is 12. Done. What is CB? 4 root 3. Done. And by the way, I don't know, I'm not quite sure why I wrote CB. I probably should have wrote BC. But those letters are interchangeable because the distance from C to B is the same distance as it is from B to C, and I kind of like to be in alphabetical order if I can. And it looks like there's the other one down there, DB. It should be backwards as well. But it's not wrong, it's just what I prefer. All right, let's find side AB. That's 8 root 3. Side AD, 6 root 3. And side DB, which is 2 root 3. So I suppose I could have circled this 8 root 3 that I had on my hypotenuse for AB. AD, I could pick up from here, 6 root 3. And then BD was 2 root 3. So those are actually the 5 things that show up inside my original triangle. Alrighty. I think we're good to go. We're good to go. Let me see. Is there anything else I can think of to mention to you? Yeah, I think so. This DB over here, this 2 root 3, I'm going to put it right here, 2 root 3. And this 6 root 3 right here on AD, this is 6 root 3 on AD. If I take 6 root 3 and 2 root 3 and I add them together, and it's like taking 6 apples and 2 apples, you end up with 8 apples, and that gives me 8 root 3. It's also like taking 6x plus 2x and calling that 8x. You don't do anything with the root 3's as long as you're adding. That's the kind of term it is. That gives me 8 root 3. And sure enough, look, this whole hypotenuse was 8 root 3. So that's kind of a neat check you can do for your work. Alrighty. Let's see where we are here. Oh, look, you guys. Aren't you excited? I have some extra problems for you. Solve each triangle for x and y. A bank of answers is provided. Cross off answers from the bank as you progress through the problems. Each answer is used exactly once. So instead of just giving you some problems to do, I actually supplied you with an answer bank. So, you know what really kind of rots is that I can't get these just a hair bit smaller for you. But you know I can, don't you? Okay, let's just take a minute and I will do that for you. I'll just shrink these suckers down for just a moment or two. And we will get it all on one page for you. Sorry that that didn't happen before. Let's shrink that down a little bit. Let's be very careful on that one. And we'll shrink this down a little bit. And then I'll, yikes, get back over here. Come back over here. Okay. And let's do this again. Let's take you, shrink you down a little. And then let's just move you up a little higher. I'll do the same thing here. We will shrink you to, hey, where'd that end come from? I don't want that. Let's go ahead and take this. I want that gone. And we're going to shrink you down a little bit. Move you over here. Take you, shrink you down a little bit, move you up. And I want to know what that is. Made it go away. There we go, everybody. Each answer is used exactly once. So your job is to solve for x and y. Use each answer one and only one time. Show me your work completely. Okay, so you want to do this on another piece of paper, and then you can upload this into our Teams, and I can check your answers for you. All right, be nice and neat. All righty. So it only leaves me with one more thing to say, and that is talent out. Cuckoo.